The next type of pollution we are going to study about is soil pollution. Although there are several ways of soil getting polluted, the main way that we are going to talk about is through the use of pesticides in agriculture. Now, what are pesticides again? Pesticides are nothing but synthetic toxic chemicals that always typically have ecological repercussions. Now, let's see why. Most pesticides that have been created are not biodegradable in nature, which means once used, they do not decompose or degrade on their own. The second is that they are typically water insoluble, which means it's very difficult to directly wash them away. Now, if any organism consumes anything that has pesticides in it, the pesticides will remain in the organism even after the organism starts decomposing. And if these organisms start going into the food chain, the pesticides keep going up in the food chain, they do not come out at any point. Now, what happens because of this is the concentration of the pesticides keeps adding up as you consume more and more animals or plants that are already infected by pesticides. And now this creates a paradoxical problem. Why? Because pesticides in the first place were introduced to keep plants weed-free, insect-free. If you dilute the pesticides, the plants will no longer remain insect-free, which means the quality of the plants gets degraded. If you add too many more pesticides, the plants automatically get affected by the pesticides itself. You might have noticed that all the repellents that you use, let's say a mosquito repellent that you use in the house, if it is ineffective, it will not drive away the mosquitoes. But if it is effective, it is going to harm you as well. And that is the paradoxical nature of these pesticides. That is another big question mark for us today. As we've kept evolving and we've created better pesticides which have lesser repercussions, we've also noticed that most insects today have started getting used to or immune to the pesticides, and they're no longer becoming effective. And as you start increasing the difficulty level of the pesticides, they start becoming harmful to mankind as well. Now we are going to look at two concepts that, although are opposite to each other, are extremely interconnected as well. The concepts are that of industrial waste and green chemistry. You all are aware that industries contribute significantly to our pollution crisis. Industries typically create two types of wastes. Either they could be biodegradable or they could be non-biodegradable. I'm sure you all have heard of both of these words enough in this chapter, so I'm not going to stretch them too much. The typical biodegradable wastes are created in cotton, paper, textile mills, etc. because most of the byproducts formed over here are biodegradable in nature. On the other hand, there are thermal plants, steel plants, fertilizer industries, etc. which typically create non-biodegradable wastes. Waste management for these industries is extremely critical to ensuring that we are leaving a better environment for the future generations. This concept has been quite important in today's day and age, which has led to a new field in chemistry called green chemistry, which means that we start looking at chemistry from a very different lens. We ensure that we still get the desired output that we want, but we are much more consciously using reactants, we are much more consciously changing the catalysts that are used, and we are starting to care about the byproducts that are being created in each of the reactants or in each of the reactions. Typically, there are several principles in green chemistry. In case any of you all are interested, you all should look up this a lot more further. In the scope of the syllabus, I'm going to give you a couple of examples to understand the concept of green chemistry. Let's take the steel plant industry for example. The typical byproducts created which are not useful to them are fly ash and slag. Now these used to be typically disposed of, which would harm the society, which would harm the environment around them, until we started realizing that those byproducts are actually useful in the cement industry as raw materials, which means the steel industry and the cement industry just started working together with each other to ensure that the wastes produced by one were being used by the other. There are several other ways of changing your reactant, still meeting your end goal without harming the environment. For example, typically to clean clothes, we used to earlier use tetrachloroethene, which used to affect the groundwater and is also suspected to be a carcinogen. Soon we started iterating on this, and scientists came up with better ways of cleaning clothes, which is by using liquefied carbon dioxide and detergents to dry clean clothes instead, which also uses lesser water and conserves water. In several other ways, in bleaching purposes, we used to earlier use chlorine, which is actually harmful, and hydrogen peroxide has proved to be a better source, which also reduces the amount of water being used again. So to summarize, we started now realizing that it is not only important to continuously evolve in technology, but it is also important to keep the environment in mind while we are advancing in our technology.